Welcome back to ECS. So this is the Entity Component System, video number 6. So let's start talking about systems. Systems are kind of non-trivial. Here in our old giant diagram, I drew this, which mostly I was trying to talk about sparse arrays and things like that, but this works as a really good way of thinking about different components. Because what we have here, let's see, I think I'll just add a layer entirely. What we have here is this, right? These are the different entities themselves across the top here, right? These are the different entities. So entities are going to have, and then these are the components. So, the player, all these guys are going to have different landscapes of entities. So let's think about different systems that we're going to have using this stuff. So let's do it like this. I'm going to get rid of this guy. Now, instead of having entities, let's start talking about systems. Which systems need to care about which components? So let's start with a basic, because these are all the different components here, and I'm not going to do a whole bunch of these, so I'm just going to erase a few of these for now. And I'll do them in another color so that it makes sense. Okay, so let's start with one of the basic ones, like what does render look like? So probably we need to have a transform, a render. I don't think we need any of this other stuff. What about, some kind of AI update system? Well, probably we always need to know about transform. We need to know about physics. We probably need to know about health. That seems reasonable, right? What about there's probably going to be some kind of physics system, which probably needs to know about physics and, look at this one. Physics and this. I don't know that it needs to know about much of anything else. There may be some kind of NPC system, where I can talk to people and they maybe have a name. It might need to know about AI and probably needs to know about transform. Right? So we have all these systems and they need to know about sort of these different entities that exist. But we don't care about the entities. We care about the components. Really what I want is, when the AI system gets an update, what are all of the different entities that I have that have, basically it's like, what entities do I care about? Well, I care about all of the entities that have these three components, right? So I care about the entities that have the intersection of these three components. I don't care about anyone anywhere else. If anyone is missing any of these three components, I do not care about them. Somebody has an AI and a health component but no transform for some reason, I don't care. They're not in that system. I just have to trust that they'll be updated somewhere else. So, we could keep going on all of these different types of systems, and it looks like I've covered at least all of the components. And there's tons and tons and tons and tons of these things, right? And then you could always say, oh, you know what? We actually, if you're doing AI, maybe sometimes we do care about physics or whatever. We could also set up interesting things where, some of these are optional, right? Maybe physics, they might have a physics component. And so we could do all that stuff. Right now, I'm not going to do that. Because I think we're going to do requirements for now. The optional components, I think, is reasonable. And I think that there's a couple of really basic ways to do that where we can just ask the question, hey, do you have this? For example, an NPC component, maybe this is optional. Health is optional. And if health is there, we show it. If not, then we don't. So we could do something like that. That's a possibility. So these are just some of the things to kind of consider when we consider this stuff. So how do we do that? I think I want to start by talking about the component system itself and talk about how I want to dig through this. I think what I want to do is I want to have a system where as much as possible at compile time, I know what components there are, like all the components, all the entities, whatever, at compile time. As much as, I mean, obviously not the entities, but I want to be able to like grasp these things in some way. And there's this kind of a way to do it. And it gets complicated. And I'm sort of dancing around this issue. Okay, let's just do this. I'll try and explain it as best I can as we go. We actually need a new file entirely because we need to have an additional layer. This is actually where I want all this stuff. No, source. And this is going to be under... I guess I put everything under entity system. That's fine. So I'm going to create a new thing that I'm going to just call base system. And I'm calling these component systems. So I'm going to say base component system.h. Here it is. Base, come on, component system.h. So my base component system is going to have these very core functions. And it's basically, where's my original component system? Oh, here it is. So I'm going to start with this as a basis. And I'm going to call this base component system. So this is the top of the food chain. Now, I do want to have this entity manager. I think it's something that we're going to... do I want to include this now? Entity manager. Or declare this guy. MP entity manager. And we could hide this around a getter or something. But, you know, I think I want to do this for now. Just some protected thing. We are going to have a constructor now because we have base component system, entity manager, right? We're going to have to pass this guy, p entity manager. And then this is just, you know, this is all basic stuff, right? Nothing crazy here. I'm going to mark this as explicit so that, you know, I can't pass in something else or whatever. I am going to have a virtual destructor. It's just going to be default, but this makes this a polymorphic base class. Which is about to be sort of made obvious. Let's do... I don't actually care about initializing this. What I care about is whenever an entity is created, I kind of need to know. And you'll see where this all this comes in. And don't be too afraid of some of these polymorphic, like some of these virtual functions. Add for declare. Sweet. Okay. This is what it's going to look like. And I'll explain this as we go and what these functions are for as we go. But this is the basic idea of what the base component system looks like. All component systems basically inherit from this, sort of. You generally are never going to inherit from this. You're generally going to inherit from the actual component system itself. The component system itself is where it starts getting nuts. So let's go to component system. We're of course going to have to include base component system. And we're going to inherit from base component system. Now, what I want is the component system needs to kind of understand a number of different things. A component system is going to have a reference to every single component that it cares about. And I'm going to make it protected. And it's going to be sort of crazy. Let's just look at what this looks like. So EASTL vector. Okay, great, it included it. So I'm going to say comp tuple. So we're going to do this as a tuple. And we're also going to kind of pool this. I'll talk about this in a minute. M components. Here are all of my components. And now go away. Now, what's a comp tuple? Well, a comp tuple, and I'll even make this protected, looks like this. EASTL tuple, EASTL add, this is where it gets crazy, add pointer t comps dot dot dot. Good God, right? So what this actually is a tuple of component pointers. We now have a list, a vector of every single component as a tuple. It's just the 3, 4, or n components that we care about. Okay, so we're missing a few things here. We're missing comps. Well, this is part of why we wanted to do this sort of base class thing, because comps is a template. It's specifically a variadic template. So component systems have this variadic template. They are a template class. All of the components that we care about go through this. I'm going to show you an example, because I think showing an example of what we want the code to look like is best. A lot of times, I learned this from a friend of mine who he asked me this question once, like years and years ago when I was working on The Sims. And it was like this eye-opening question. It's such a stupidly simple question, but it was this eye-opening question for me, which was, hold on, entity system, which was, what is the code that we want to write? And so I'm going to say render system public component system, and then renderable transform. Now, of course, since we're using these, we have to include these, but that's fine. We would have to do that anyway. So entity, here we go, components, transform component, come back to me. And then this is going to be renderable. I wonder if we could forward declare these. Probably not. Oh, you are transform component. There we go. This is the code that I want to write. And I can do using base system. This just makes life easier so that I'm not doing component system bracket, this whole long thing, right? So this is literally component system. It's these guys. So that anytime I call some base class thing, I don't have to do this. So it's a little annoying here, but that's it. And then here, all I'm doing is I'm overwriting stuff. I mean, I do have to do render system, entity manager. Like, this is sort of annoying. P entity manager. But now, I can just do base type P entity manager, right? I don't have anything special here. That should work. I don't know why you're complaining. Cannot initialize base class base type with L value entity manager. That seems wrong. Entity manager, P entity manager. I don't know why you're complaining. I'll care about that in a minute. And then, I've mentioned this before. Double delta time or whatever, right? Where I'm okay with having this single virtual function. This is kind of what we're going for. This I find interesting, and I don't know why it's complaining about my base type here. I think it's complaining about my base type here because I'm having, this project is nowhere near being able to compile. So we'll care about that later. Let's see, entity component. So yeah, this is kind of the code that we want to write. Even more than this, what we want to do is we want to, I'll just show you kind of what this code could look like. Let's actually build this guy. Generate implementation of function. So here's how you would loop through all of these things. You would do something like for auto whatever comp tuple in m component, because we've exposed it. And then you could say transform component star p transform equals, you would just grab this, EASTL get, and you could do it, C++14 lets you do this pretty easily. Comp tuple. I know this is ugly. C++ tuples make me long and pine for Python tuples, which are super easy. So, it's just this, right? It's renderable. There you go. And you could auto this or whatever you want. So you do this. That's it. And then, right? Like, do stuff to render the thing, right? That's it. This loops through only the things that have the intersection of these two components. That's the code. I mean, that's it. That's what we're going for. And so you might do like P, I'm just going to make stuff up. P renderable. What did I actually do for renderable? I created a texture of 512 and then did nothing. Great. So I might, mp renderable dot mp texture bracket 0 equals static cast p transform dot get. Whoops, not dot get. I'm so used to old school stuff. M position dot x. Right, like, I don't know. I'm making stuff up. Obviously here you would do your actual rendering, but this shows you how you would do it. You just loop through all the things. There you go. That's it. That's everything. So that's what we're going for. That's the idea. So let's figure out how to get there. And we get there through this extremely complicated component system. Okay, so let's go back to component system. Let's talk about how this is going to work. I'm going to kill all this stuff, and we're going to go to base component system, and we're going to grab these guys. These are all public. And so we're going to grab these guys. Okay, now, one thing to think about here is that, I think this actually might be what it was complaining about. I think I have to actually add this guy in here. I'm curious now, did this actually fix this? Yeah, that fixed it. I knew it was something stupid. Okay, here's the thing about this created and destroyed. Override. I don't know why I said equals. Override. We're actually going to do override final because these can't be overridden. These are entirely for this. There's sort of a whole reason why I have to do this. Although I wonder if I could do it in a different way. But this is the way that I'm doing it for now. I'm actually not going to define update at all. You cannot instantiate this. I still want this to be a pure virtual thing. Okay, here's where it gets really nuts. The way that this is going to work is when an entity is created, like this on entity created, what we're going to do is we're going to expand this guy out, and we're sort of gonna loop through the entity, grab the components, and do like a sort of internal process on them. Let's look at how that's gonna look. Can I just do the easy thing? Yeah, great. This is our thing. So what we want to do is we want to loop through all the components on this entity and see if any tuples match, which is maybe not the right word. Comp tuple. Size t matching comps, right? So this is the number of matching components that we have. And then we're going to loop through the stuff. So for comp pair in entity.getComponents. We're probably going to have to include entity, so maybe we should do that. I actually don't think entity compiles. We'll probably have to fix that briefly. And so I'm going to say if, and again, I'm just going to sort of write the code that I want. Process entity component seems reasonable. 0, and then we have to pass in the components. This is kind of classic-ish variadic template. That's what I'm looking for. Recursion. where you're sort of looping through. This is actually going to be even cleaner in C++17. Where you're basically looping through all the components. Let's write that function briefly. So process entity component is going to have kind of two types. So this is going to like recursively, which I feel like I spelled incorrectly, recursively looks through component types. And that's this version. And then there's a second version, which is the termination. So like this is the termination. I'm just going to write the thing here. Specialization of the recursion. So this is, again, pretty classic, which happens when we no longer have a comp type that's passed in. Okay, now that I've finished typing all this stuff, I can finish my thought. What you're about to see, if if you haven't done a lot of like variadic template stuff, pretty common. This is also kind of template metaprogramming-ish stuff. It's pretty common to do this like recursive loop, where you're sort of you're recursively processing every element in the parameter pack. And so you have two functions, one that's doing the processing and one that is doing the termination. And so the way that looks like, I have a size t, which is the index that I'm using right now. I have the comp type, the thing that we're processing now, and then comp args. So the way that this works is the variadic template is going to try and match this thing. And as it does, so I'm passing the arg, say I have transform renderable on here. When it reaches this function, it's going to say, okay, so transform renderable becomes transform goes here and then everything else goes here. So we'll say transform renderable in physics, right? Transform will go here, renderable in physics will go here. Second time recursing through, transform is already processed. So now we're doing renderable here and physics here. And then third time through, physics here, nothing here. Final time through, nothing. And then this would actually not even match the final time, which is why we need the exit version. So this is going to take in the component ID, which is what I have down here. That's first, right? So component ID is the comp ID. The second one is the component itself, component star p component. And then the third one is the tuple to fill. This is sort of our output. We're recursively walking through filling the tuple with the actual value. So this is how we're filling it. Your entity component, right? Yeah. Okay, let's generate this function. This will be fun. Just so we can see what this guy looks like. What we want to do here, this process entity component, basically we say if comp type ID is equal to comp ID, right? This is the ID that we're looking for. EASTL get index. So now we're setting it by index. Tuple to fill, right? Get allows us to set things. We do static cast because we're sure that it's the right type. And now it's exactly the right type, right? We just do this set, and then we're done. Like, we have successfully done this. So what this does is it says, okay, if the component ID that we're currently looking at, that was passed in, is the same as the component ID that we've passed in for this guy, then we set it. Otherwise, like we set it in the tuple. Otherwise, we keep going. And so this is sort of our loop. We say index +1, comp args arts args . And same thing, right? We pass in the comp ID. We pass in the component. We pass in the tuple. And that's it. This should be a return. And so that's what this is. And now we need, of course, the termination condition as well. The termination condition looks almost exactly the same. It's the same signature, except no component was passed in. And so this will match once this sort of component args parameter pack is empty. So we have to generate this version of the function. And I know, I told you this stuff could get complicated. And this is literally return false. That's all this is. False meaning we're done. Now, you know, this guy's probably giving me warnings. Oh, it can be static. It's fine. You know, there's issues like we're not using these 3 parameters and all sorts of stuff. Well, you know, that's fine. That's the price that we pay for greatness. Okay. Now what we're missing is this internal sort of loop. Now we know what process entity components is. If this succeeds, you know, then we've got some stuff that we have to do. So if this guy succeeds, then we say, yay, oops, matching components. We have an additional matching component. If matching components is equal to size of ... comps, in other words, if it's equal to the number of components that we have, then hooray, components dot and place back, and we'll do a move. I don't actually know if this is going to help us. Comp tuple, because they're all pointers, but whatever, we'll do a move, and then we'll bail. We're done. That's all that we need. This is our entity on entity created. This doesn't seem to happen. Yeah, we have to revisit entity. We have another thing which is on entity. Whoops, destroyed. Uh-oh. Yeah, that happens sometimes. Let's go back here. I think I have 2 S's here. All right, there we go. On entity destroyed, we'll do the same thing. And in on entity destroyed, it's you know, we have sort of a similar thing, but really we're just saying const auto find it equals m. So this is where we need a new thing. Because what's going to happen is an entity is destroyed, and we want to say, okay, we need to destroy the thing that's there, right? We need to destroy your entry in our vector. So I think it's worth eating up a little memory. To do this. Entity ID, size t, EASTL, hash, entity ID. This should work. What are all the stupid things? EASTL equal to entity ID. And finally, once again, our pooled, you see me, I've commented it out here, because we have to talk about that in a minute. So I'll actually do the same. Pooled allocator. Bam. Because again, we want to pool all of this stuff as much as possible, so we're not just calling new all over the place. Entity ID to index map. Entity ID to index map. There we go. Okay. So then down here, where are you? Down here. This guy. Oops. You know, we can grab the thing. We're looking for, do I want entity? I might not actually care about the entity. I feel like I don't. I think I just care about, I mean, not that it matters. I think I'm actually just going to pass in the entity ID for this guy. That means I have to change a couple of things here. Let's just pass in the entity ID. I like passing in sort of the minimal set that I need. You don't know what entity ID is. Is it in entity.h? No, it's here. It's an entity system types. That's what I actually want. Entity system types. There we go. Okay. Let's go back out here to our component system. So, anyway, so we're gonna grab this. Obviously, this might help. Entity ID map. I'm gonna forget to do this. Not that emplacing really does anything here, but let's do it anyway. So we're gonna emplace. What did I say it was? So it's the entity ID to the index in this particular case. So we're gonna say, yeah, that's emplace back. So that should be fine. Entity.getID. Components dot size -1 basically. So we update this map. Yeah, that'll help. Okay, so now down here, what we want to do is now we say if find it not equal to, right, this is just our normal thing, entity ID map dot end. So we're going to do kind of the move trick. So we're going to move the back element to overwrite, come on, overwrite this one. Jesus, I can't type anymore. So m components, find it dot second equals move m components dot back. This is sort of the swap trick. I actually mentioned this in one of my other videos, where you can kind of do this sort of thing, which is pretty sweet. I'm just moving it back here. It's a constant time removal from this vector. I don't care if it's sorted. So, you know, in my little kind of demo thing that I've written here, I'm just going to copy and paste this comment. It's a big block comment that explains what we're doing, right? So we need to figure out which entity the moved component belongs to so we can update the ID index map. So all the components in a single tuple are owned by the same entity. We can just grab the first one that's queried. So now we do const auto star p moved component equals eastl get 0, right? It doesn't matter. M components find it dot second. So what we're doing is we're grabbing the component. I don't care what component it is, but we're grabbing the first component from this thing. That's all we're doing. And so now we want to now we want to find the entry for the moved ID and update it with the new index. That's it. So auto moved tuple iterator equals m ID map dot find p moved component. I like moved better. Dot get entity ID. And then we can do like an assert here. Check is my is what I use in my own sort of engine. It's my own thing. So we should say moved tuple it not equal to m entity ID map dot end. This should never happen, right? Should be impossible. Which of course means that this will almost certainly trigger at some point. Moved tuple it dot second equals find it dot second. That's it. This updates the ID basically. So this grabs the thing that we just moved. And then this find it dot second, this find is the old thing that we just overwrote. The second, of course, being the index. So we're just overwriting the index in that dictionary, in that hash map, so that all things are good. Should be it. That should be all that there is to do. Yeah. I'm not actually sure if I'm initializing it. Oh, I am. Okay, good. Great. So that's it. That's what we've got. So that's the idea. Now, we still want to be able to deal with component systems and updating them and all that stuff. That's why we have a base component system. It has no templates. It's unencumbered. We just call the virtual functions and then they magically happen. Down here in the actual component system, this is the complicated version. Any component you create inherits from this component system and does all this magical stuff to make the tuples just work. So, our render system should basically work now, I hope. All this stuff should pretty much be there. We should be good to go. So that's kind of it. There's a few, miscellaneous things that obviously we're going to have to do. So let's go to Entity Manager and see the various things that we have here. So we have all of our systems, all of our components, all of our entities. Big few things that we're missing. We haven't done any of this pooled allocator stuff. And I'm going to do a whole separate series on this. Because memory allocators are not super easy. So what I want to do is add a new item. I'll just sort of briefly create the thing. Come on. No. Memory. And talk about what it's doing at a very, very high level. Memory.h. Let's call it main allocator.h. I'm literally going to copy and paste this. So all this is a relatively simple kind of allocator that inherits from like this bleach allocator that I have. It's just a basic distributor. The idea is that whenever it has a number of pools, and whenever I try and allocate memory, it tries to figure out which pool is the smallest pool that can possibly contain the thing, and that's the idea. That's what it's trying to do. So I've just sort of tuned it to be the thing that I feel like is the right thing. Like I said, I already have a system that kind of does this. I've mostly grabbed this from my own engine. So now I can go in here and say, pooled EASTL allocator is also sort of its own thing. So let's grab that guy, entity component. So in order to do that, let's grab that. I should just be able to include it directly. Debug. Oops, not debug. Memory. EASTL allocator. So now I should be able to kind of undo these guys. There we go. That's better. So, it makes it less terrible to allocate all this memory. That should pretty much be it for these guys. I'll probably after the ECS stuff, my next push will be simple pooled or memory allocators. That seems like it'll be fun. Okay. So now it should basically work. How much time has this video gone on? So kind of a while. I want to do something that's kind of missing and talk a little bit about entity. We haven't really touched this since kind of the beginning. So let's think about what this is going to look like now. So entities still have an ID and they still have a component map. I'm actually going to do this sort of using component map here equals EASTL hash map. You really have to do this stuff for some of these things, right? Component ID, some component pointer, which I sort of already have here, right? And come on, entity component. I'm just going to copy and paste the rest of this stuff because it's kind of the same thing that I have going on, which is this pooled allocator. Yes, include that. And let's see, let's jump back to this guy. Component map. So that makes that a little better, I guess. Entities know their own ID. That's fine. One thing that I do kind of want to do is I want to allow entities, I'm just going to copy and paste this as well. I don't want to allow them to copy, but I do want to allow them to move. I want to be able to move entities wherever I want, but I don't want to copy them. That sounds like a terrible idea. Entities have a sort of get ID, which is valid and fine. They have a get component, which I think is also probably fine. I'm also going to do this const component map get components, right? We know that we need to be able to get all of the components for systems. So let's just add this guy right here. This is easy, m components. So this is another kind of getter that we need. And then sort of the final thing, there'll probably be an initialization. I would almost certainly add that as well. Component ID, comp ID, component star p component. And I probably don't need a lot of this other stuff either, but it's fine. So we'll do some kind of like check m components. Oh, I'm gonna need to add you, aren't I? Come on, there we go. M components dot find comp ID. ID is equal to m components dot end. So this makes a very direct statement that we can't have duplicate components. M components dot in place comp ID p comp. That's it. That's what we got. And we could probably get rid of all this crap too. We could probably just say, hey, entity component, what is your ID? We have an ID. Yeah, I mean, it's probably simple enough like this. Like, we don't really have it on this side, right? Because it's on the internal side. We could make this a component, or not a component, a template, right? Add template. Yeah, we'll see. We'll see what this is. Right now, I'm just going to leave it like this. So this is a more complete entity class. I have a CPP file. I don't think I need it anymore, although this freaked out here. Oh, hash code. Oh, there's something broken in this somewhere in here. It's probably because of this component ID. It shouldn't be. Yeah, so something broken here, Oh, I know why. Because of this guy. Entity component type hash. This shouldn't matter, actually. I should just be able to do EASTL hash component ID. This should work. There we go. So many template components. Okay, so that's it. Now we have entity. We have entity system. We have a bunch of stuff. Let's go to entity manager. This stuff should all be pretty good. Types and all this kind of stuff. I think this might even just compile at this point. I don't actually know. It's unhappy here. It doesn't like delta time. That's fine. We'll just not update you oh yeah, and you're done. We just won't update any of this stuff. But I think like all the interesting stuff probably compiles at this point. I don't know. I'm afraid to hit F7. Let's see what happens. It's not as bad as I thought. I'll probably just fix these like the various compiler errors and maybe just mention what they are. And for those who are interested, literally all I had to do, I still had the old component system in here. So I just changed it to base component system pointer, because that's what we're using here. And then the only other things are like stupid things in here, like, oh, this should return a value, just temporary stuff. Okay, so that's basically it for systems. In the next video, we'll talk about actually instantiating some of this stuff and maybe run some tests and things, because that's the big thing that we're missing, right? All this entity manager stuff and how to actually create components and systems and entities and all that kind of stuff and how it all sort of gels together. So that's the next step, and we'll cover that in the next video. See you next time.